Hello YouTubers, welcome back to my adventures in urban gold mining. Okay, so if you're into, recovering gold from electronic waste like I am, you've probably come against the same problems I have. How to get the gold off of all this stuff quickly and easily. Now, fingers, it's fairly easy. You can put them in AP solution, let them soak for a little while. The underlying base metal is going to be dissolved away, and the gold's going to fall right off. Okay, fairly easy. Now, if you start to apply that to this other stuff, it doesn't work as well. I mean, there's a fair amount of gold on these connectors here. Both on the, I don't know if they'll show up, but get it out in the sun. There you can see the gold. There's gold there, and there's gold on the inside. But there's a lot of base metal here. There's a whole lot of base metal here. And then these barrel connectors, they're mostly base metal. Just a little gold plating on them. And it'd take weeks to dissolve these, at least in AP solution. And it's very inefficient. And I've got little gold boards here that have some gold plating on them. And how to get that off. And I could put these in AP solution with the other stuff, but all the components are going to wind up mixed in with the gold. With the barrel connectors here, the insulating parts, the Teflon insulating parts inside, and the ends of the coax cable that are in there are going to be mixed in with the gold. All the little bits and pieces that would dissolve out of this would be mixed in with the gold. And even doing fingers, separating the gold from the fiberglass pieces that's left is a pain in the ass. So I've always been looking for an easier way to get the gold off this stuff without having to dissolve away the base metal. If there was something out there that would just dissolve the gold and leave everything else, well, that would be ideal. And I have searched and hunted, and I think I finally found something that works pretty well. And let me show you. There's a company called Eco-Goldex out there, and I have no relationship with them. So, I'm not getting paid to tell you this. This is just my own personal experience with it. They make a product, Eco-Goldex E-Series. They call it a simple and effective gold stripping reagent. I wouldn't call it simple, but it is very effective. There's a bit of a learning curve with this. I did a lot of research on it before I bought it. And basically everybody on the forums was poo-pooing it, thinking, oh, it's just another cyanide leach. Nothing new about that. Toxic as hell. Well, I bought some anyway, just to give it a try. And I was prepared to have to use all kinds of PPE while I'm working with it. Cyanide leach. That sounds pretty dangerous, yeah. But I got to watching the videos. They've reformulated this recently, apparently. It's not the same old Eco-Goldex. It's a different formulation. In the videos, you see guys using this stuff, no PPE at all. They're not wearing respirators. They're not even wearing gloves. They're getting it all over their hands. Now, I'm not sure I'm that cavalier about it. I wear gloves when I'm working with it. It does not evolve any kind of nasty fumes. I will grant you that. It's not like dissolving gold in aqua regia, or even dissolving this stuff in AP solution. There's no hydrogen chloride fumes. There's no nitrogen dioxide fumes. There's no real fuming at all when you're working with it. Now, I am a little bit leery of it because it does contain cyanide compounds. And, if you were to drop the pH on this too low too quickly, you might get cyanide to evolve. Now, I'm not enough of a inorganic chemist to figure that out, but I do know enough to know that would scare me a little bit. But as it is, it's a very basic solution that this makes. Up around 12 to 13, and I got to tell you, this stuff works. I was amazed. I mean, the videos, they make it look like magic. You mix this stuff up with water, you put the gold-bearing stuff in the resulting solution, and in a few seconds or a minute or two, the gold is gone. And I'm like, it can't be that good. So I bought some. This is their 1 kilogram sample bag, and you want the Eco-Goldex E-Series for electronic waste. They make an O-Series for stripping gold out of gold ore. So that's a different formulation and a whole different process than the E-Series. You want the E-Series if you're working with e-waste, okay? So that's the easy way to remember it. And they sell this 1 kilogram sample bag relatively inexpensively. Now you can buy it in 50-pound sacks. You can buy it by the pallet load if you've got a lot of stuff to work with. Well, I got the 1 kilogram bag, and it's lasted me for several tries now. And I think this is my 3rd run I've done with this stuff. And this will be the 4th run, I guess. And I'm starting to get comfortable with working with it. I can see that it works really, really well. So I'm comfortable recommending it to other people at this point because it does work. And what I'll do in this video is I'll mix up some of this stuff and I'll show you how it works on some of this stuff. Just how well it works. It works fantastically. And in the space of an hour or so, you can run a whole lot of e-waste through it. I mean, I've got a whole bunch of these barrel connectors, piles of them, and I'm working on a deal to buy, a whole lot more cheap. I've got a bunch of fingers. I've got a bunch of connectors. Let's see, what else have I got? Yeah, here's another thing that you can run through it. Processors, pinned or pinless, that have, the gold pins or the little gold pads. There's not much gold there, and there's not really a good economical way to get it off these things. But until now, this stuff will do it. This will strip the gold right off of it in a couple minutes and leave behind everything else. So it works, and I'll show you how it works. Like I said, there's a bit of a learning curve. I ordered this stuff, and they sent it to me just like this in a bag, in a bigger padded bag, which I'm surprised it got to me without being punctured and the powder going everywhere. I store it in an airtight container. I don't know if that's necessary, but that's just what I do to make sure that it doesn't turn into a hard rock like concrete or something. So I store it in an airtight container when I'm not using it. I had a lot of questions for the guy, John, I think his name is Gao. I believe he's Chinese, who started this company. It's in Canada, by the way. It's a Canadian company. I had a lot of questions. So I was peppering him with questions for the first week or so after I bought this. And he finally said, hey, why didn't you read all the stuff I emailed you when you ordered the stuff? And I said, well, I didn't get anything in the email from you. And then he's like, oh, he was apologetic, and he says, well, that was a mistake on our part. We were supposed to email you a bunch of information on how to use this stuff. So he went back and he emailed it to me, and I got a whole bunch of PDFs in my email that tell all about how to use this stuff. And it's like, oh, well, that's great. This answered all my questions. Now I can, go forward and give this stuff a proper test run and see how well it works. Because there are a lot of moving parts to making this work. It's, like I said, it's effective, but I'm not sure it's so simple because, you got to mix it up, you got to filter it, strip the gold. You have to adjust the pH with one reagent, citric acid. Use zinc to cement out the gold. You have to go through several cementing steps to get all the gold out. The second one, you would adjust the pH with sodium metabisulfite and then cement out some more gold, and actually do that another 1 or 2 times, they recommend, just to make sure you get all the gold out of solution. There's a few things in their instructions that don't make a lot of sense. I suspect it's translated from Chinese, but I managed to figure it out and make it work. Some stuff they recommend just doesn't seem to work. Like they say you can use the Stannous chloride test to see how much gold you have in solution. I can't get Stannous chloride to work with this. I don't know. I think it's just probably the low or the high pH of this stuff maybe screwing up the test. I don't know. But Stannous chloride for me does not work with this stuff. I mean, even if the solution is loaded with gold, I get like a negative result. And but that's about the only real gotcha with using it. There is one gotcha if you buy this stuff, though. Like I said, they're a Canadian company. If you're here in the States, like I am, and you buy this stuff, they're not doing something right with their customs paperwork, and you're going to get hit with a brokerage fee by whoever delivers it to you. And you know, if you're working on a really slim margin, that brokerage fee is going to eat up all your profits. So I talked to John about that, but he kind of basically blew it off. But I think if they just did something different with their customs paperwork, the recipient wouldn't have to pay a brokerage fee on this stuff. And that's going to be a sliding fee, as I understand it. It's going to go up with the amount of this stuff that you buy. So like I said, if you're working on a really slim profit margin, find a way to get around the brokerage fee on this, or it'll kill you. But the material itself is not all that expensive. I forget what I paid for this 1 kilogram sample. It was on special when I bought it. I think it was probably $50 roughly. And 1 kilogram does a lot, because you only need about 55 grams per liter of water to make a really effective stripping solution. So it's a lot of liters worth in here. Anyway, let me, this is getting a little long in this intro. Let me get moving and mix some up. So I'm going to mix up some Eco-Goldex and give it a good test run here for you to see. I've got a whole bunch of these RF barrel connectors over here. And, you know, getting the gold out of these the old way by dissolving away the rest of the metal, it's going to take a long time, very wasteful. Going to leave behind a lot of debris that you have to separate from the gold. This stuff's just going to strip the gold plating right off and leave everything else behind. So let me get set up to mix up the stuff and get it going. I'm going to mix up 1 liter of the Eco-Goldex E solution. So I've got a liter of water on the hot plate over here warming up. It needs to be dissolved in hot water. It's just tap water. And the instructions say 50 grams of the material to the liter. Well, I have found that there's always a lot of crap that doesn't actually dissolve, so I go about 55 grams. It's a little windy out here, so that's dancing around a bit. I go about 55 grams just to compensate for the stuff that doesn't dissolve. I don't know if that's necessary or not, but that's what I do. So I'm going to mix up 1 liter of this stuff, and we'll see just how much gold it can dissolve, and then how much gold we'll get back out of it. Okay, this water's warmed up nice. It doesn't have to be boiling, just hottish. I'm going to turn this down a little bit. And I'm going to mix it up. So in goes the Eco-Goldex. Making a bit of a mess. Stir it up good. Give it a chance for everything to dissolve. The instructions say to just let the insoluble stuff dissolve, but I'll tell you what, there's a lot of insoluble stuff in there and it never dissolves. So, but I'm going to let it sit for a while, and I'll stir it again a couple of times while I set up to filter it, because like I said, there's a lot of insoluble stuff in there, and filtering that out is one of the important steps in using this stuff. So I think just for expedience, I will probably vacuum filter it, so I'm going to set up for vacuum filtering. All right, time to filter this stuff. I've stirred it up a couple of times, but there's still a lot of stuff in here that just isn't dissolving. It's hanging out around the bottom. So I'm going to filter it and clean it up. I'm set up for vacuum filtration over here through the Buckner funnel. And I know it looks weird on the video. The perspective is strange. Looks like the funnel is huge. It's a big funnel, but it's not as huge as it looks in the video. So let me get the vacuum going. And I'm going to filter this liquid through here and get rid of all of the sludgy stuff that's not dissolving out of it. I'm going to pour the liquid through first so that I don't plug up the filter. Try and leave the sludgy stuff behind for now. As much of it as I can anyway. I hope that nice golden amber color is showing up in the video of the filtrate. That's the way this stuff looks. The virgin Eco-Goldex mixture looks before you start dissolving gold with it. As you use it to dissolve gold, it'll get darker in color and kind of muddy. At least that's been my experience. And you may be able to see the steam coming off the funnel here, but there's really no fumes to it. Hard to describe how it smells. It has very, very little odor to it. It's kind of an earthy, metallic odor. It's the best way I could probably describe it. It's not obnoxious. There's the liquid, and in the bottom there's some of this nasty sludgy stuff. Don't know what that is, but it doesn't dissolve. Get this stuff all through the filter. And we'll be ready to start stripping gold. Okay. I am ready to start stripping. I've got my Eco-Goldex mixed up. It's filtered. The instructions say between 45 and 55 degrees it works best. So we're at 56, so we're just a little bit warm. But that's okay because this stuff's cold. I got between half and 2/3 of my RF barrel connectors in the bottom of this beaker. And what the instructions say is do your highest grade stuff first, and then once the stripping action slows down, use lower grade stuff to just use up the rest of the stripping chemicals in the mixture. I guess it's kind of like Aqua Regia. You can't drop the gold out of Aqua Regia as long as you still got active nitric in it, because it'll kind of redissolve the gold. You want to use up all of the gold dissolving properties of the Eco-Goldex too before you try to get the gold back out of it. Otherwise it'll just keep redissolving it and you won't get the gold out. But they say do the high quality stuff first and then finish up with lower quality. So I'm going to do these barrels connectors here first, and we'll see if it cleans all these up. I'll add some more to it until it seems to not be doing so well anymore, and then we'll see. I'll either feed it some lower quality stuff to chew on, or just keep feeding it these RF connectors until it's not taking the stuff off anymore. One or the other. So I'm just going to pour this right in here. Now the instructions also say agitation is important to keep it mixed. I'm going to put this on the hot plate on low just to keep it warm so it doesn't get cold. It says agitation is important to keep it mixed. A lot of times what I'll do is I'll put an air bubbler in it and just bubble it, but I think what I'm going to do for this test is I'm just going to stir it from time to time just to make sure everything gets exposed to the fresh Eco-Goldex. And let's see, the time right now is 10 minutes till 11 a.m. We'll see how long it takes to strip all the gold off of those connectors. And I'm just going to stir it from time to time. That's all I'm going to do. All right, it is right now about 1 minute past 11. So it's been about 11 minutes that this stuff's been in here. And all I've done is stir it a couple of times. And I hope it's apparent on the video. The color has gotten a lot darker. It's sort of like a darker amber now, a little less clear. And I'll tell you what, it looks like, yeah, it looks like a lot of this stuff has had the gold stripped off of it. Probably the easiest way to see it Well, it's hard to tell even there. Let me pour the liquid off and we'll look at what we got in here. I'm not sure all the gold plating is gone from everything, but it looks like most of it is. Some of that may just be copper down there. Let me get the phone and give you a close-up look at what I'm seeing over here. Look at that. Those connectors, a lot of them, are now gold-free. There's some down there that may still have some gold on them, but most of them look pretty much gold-free. And that's after only 10 minutes in this stuff. I think what I'm going to do is I'm going to pull out the stuff that looks gold-free so I can rinse it, and then we'll see what the stuff below it looks like. So I've got a little bit of rinse water here, just some distilled water, because these connectors are still going to be full of the liquid that's holding the gold, so I'm going to give them a little rinse in here. Find another beaker. Put this stuff in after I rinse it and catch any liquid that comes off of it, because it's going to have a little bit of gold in it. Yeah, these connectors with the pails on them, they cleaned up real quick. They must have had a pretty thin gold coating on them. I don't want to use too much rinse water, because I'm going to have to combine it with that stuff when I do the final dropping of the gold, and I don't want to dilute things too much, but I do want to capture some of the liquid. The rinse water is already turning sort of yellow-orange. Yeah, there's no gold left on those. None at all. Alright, and as for this stuff, I would say probably, I still see a few things that look like there's some gold on them. I would say 90% of it's gold free, but not 100%. So what I'm going to do is I'm going to leave this in here, put this back in. And you'll notice I'm wearing gloves. This stuff is highly caustic. The pH is somewhere up close to 14. So, I mean, in some of the videos, like I said, that I've seen of people using this stuff, they're not wearing any kind of PPE at all, but I think that's probably just a little too caustic to be getting on my delicate skin. So, I wear gloves when I'm handling it. Probably wouldn't hurt to have eye protection too, just so I don't splash any of it in my eyes. I'm sure that would probably hurt. So I'm going to try feeding the rest of these connectors through and see if it'll dissolve all the gold off of them, as well as the few pieces down below that look like they still have some gold on them. And we'll see just how much I can feed through this liter of... Well, it's been about 5 or 6 minutes since I put these in. Oh, look at that. They're already looking like all the gold's gone from them. That was really quick. That was really, really quick. Yeah, let me pour the liquid off again so I can get those out easier without destroying everything here. And the stuff on the bottom is looking a lot more stripped too. I only see a couple of things that look like they might still have some gold on them. They may have some sort of clear coating over the gold, which is why it's not stripping off. But most of it looks like it has been stripped. Yeah, there's a piece that's still got some gold on it. Not sure why it's not dissolving off. There's another piece. So I'll let them soak a little bit. This has got paint on it, which is why, okay. The gold came off where the paint was. Wasn't, where the paint wasn't, I should say. Okay. I'll just let these soak some more. Yeah, there's still a few pieces in there that have gold on them in places. It must be much heavier plating than these connectors with the tails on them, because they clean up pretty darn quickly. But notice how dark the liquid's getting. The more saturated with gold it gets, the darker it gets. Well, I guess I'll put the rest of these in, since it seems to be stripping still pretty efficiently. And I'll have to find some other stuff to strip to use up the rest of its stripping ability. All right, we'll let that go. I'll be back. Well, it's been about another 10 minutes. Stirred it a couple of times. Yep, those connectors I just put in are stripped. All right, let's get a better look here. Yeah, they're stripped, and the stuff that on the bottom is looking better too. There's not much gold left in here, if any. Yeah. There's some stuff that's copper. Copper plated or solid copper. I can't tell which that the gold's been stripped off of. But I don't really see any more gold in there. So that's pretty good. I need to find something else for this to chew on to use up the rest of its gold stripping ability, because according to the instructions, I won't be able to get the gold out of it until I use up its gold stripping ability. Although I think some of the steps in the process of dropping the gold require drastically changing the pH, and I suspect that actually retards its ability to hold on to the gold. But, you know, we'll follow the directions. And I'll give it some more stuff to work with. I've got a whole box full of stuff here. There's some gold-plated connectors. Let's see, there's a little CPU chip with tiny gold-plated pins. I got a lot of gold fingers in here, a whole lot of gold fingers. Some PC boards with some gold plating on them. Here's a pretty heavily gold-plated connector. So what I'm going to do is I'm going to put some of this stuff in the beaker. And just let it dissolve off the gold. See if we can use it up. I'll do the fingers first, I think. Give it a goodly number of fingers to work with. Back on the heat. I have to rinse these a bit. I'm using distilled water for the rinse. I don't know if that's necessary, but seems like a good idea to me. I'm going to rinse them a couple of times with just a minimal amount of water to because I don't want to dilute the solution so much that it kind of fools me into thinking that it stopped working, when all I've really done is just dilute it. Rinse them until I'm not seeing any more yellow color come out. That looks pretty clear. Whoops, get back in there, you. So, half hour ago, this is all gold-plated stuff. Now it's just scrap, ready for the garbage. That didn't take very long. And we'll see how it does on these gold fingers. I'm starting to see some reaction already, but this may use it up. We'll see. I'll let you know in a bit. Alright. The stripping of the fingers seemed to be taking a little while, so I went into the house and had a little lunch. I've been gone about 35-40 minutes to come back. It looks like they're pretty well stripped. I think I'm going to have to pour off the liquid to get a good look at them and see. So I don't know if that's showing up on the video. Let me get around and look at the camera here. The gold, well, not entirely, almost entirely gone. There's a few pieces in there that still have a little bit of gold on them, but it's almost all gone from the looks of it. But obviously the stripping speed is slowing down dramatically. I'm going to put this back in here and see if I can get the rest of the gold stripped off of the bits that still have some on them. And I need to use up the rest of the stripping ability of this stuff. It looks like we're getting close. I might put in a few more fingers. Yeah, here's a few more fingers. I'll put these in right up here where I can sort of keep an eye on them. And we'll see if we can use up the last of the stripping ability of this bit of Eco-Goldex. And then we'll move on to the next steps. Gonna let it sit for a little while. Alright, it's been about another half hour. Let's have a look at this stuff. It certainly seems to be slowing down in its stripping ability. Oh yeah. There's one of the last pieces I put in. It's still got a lot of gold on it. So it's been in there for quite a while. Yeah, there's another one. So yeah, I would say it's about done. This one's still got some gold on it. Yeah, that side's got a lot. Alright, so I'm going to call it done because it hasn't stripped those fingers off yet, and that's pretty thin gold. So what I'm going to do is I'm going to rinse this stuff off like I did the connectors. I want to get the pregnant gold solution out of here. And then what I'm going to do is I'm going to pick out the fingers that still have some gold on them, and I'll add them back to my collection of fingers here for use next time, and the rest can just be discarded. I'll give them 3 rinses, I guess. That should get most of it out. Alright. So I'm going to pick through this and pull out the pieces like that one that still has significant gold on them. Put them back in there. There's a couple more in here. Got to find them. And then the next step, this needs to be filtered. It's pretty muddy looking. It's darkened up, it's muddy, it's got some sediment on the bottom. The instructions say this should be thoroughly filtered before moving on to the next step. So I'm going to set up for vacuum filtration again, just like I filtered it after I initially dissolved it near the beginning of this video. I'm not going to show it because this video is going to be really long. We've got the gold in the liquid, okay? That was fairly simple. Getting the gold out of the liquid, there's a lot of steps involved, and this video could be hours long unless I start cutting out repetitive parts. So I'm gonna just vacuum filter this again, and I'll start with a nice clean liquid, so you'll just have to take my word for it that I do it. I'm not going to show it. And I'll probably skip a few other steps along the way, but I'll explain what I did even if it was off camera, just to make this a little shorter, because there are a lot of steps involved to getting the gold back out of this liquid. Alright, so I'm going to sort through this, filter that, and I'll be back. Alright, the liquid has been filtered. It's very clean again. The instructions say for the next step it should be around 40 degrees C, 46, so it's a little hot. But I turned the heat off. The next step is we need to adjust the pH of this solution to somewhere between 6 and 6.5. Alright, well, we got a long way to go. I got some pH test strips here. These are just your regular cheap pH test strips that give you some rough idea, somewhere between 1 and 14 where you are. These are more accurate if you get into the range of between 4.5 and 9. So what I'm going to do is I'm going to adjust the pH roughly with these until I get down close to the range I want it. Then I'll adjust it more finely until I get it right where I want it. And they say the instructions say to use citric acid to bring the pH down. So I have a really strong solution of citric acid here. It's, I would say, probably a saturated solution of citric acid. You can use the powder, citric acid powder, and I've done that, but it's really easy to overshoot your pH target using the powder. And also it gets really, really foamy. The lower the pH goes in this, the foamier it gets with each new addition of acid. Not sure why, but that's just the way it works. So I have found that using the liquid is a little safer. I'm less likely to overshoot, and I can control the foam better. Well, let's see where we're starting out pH-wise here. Oh my, that's deep purple there. I would say that's right about 13. Right around 13 right there. I don't know if that's showing up on the camera. But we are a long way from 6 to 6.5. On the other hand, like I said, it's really easy to overshoot. So what I'm going to do is I'm going to add a little bit of the liquid, lots of stirring, because it takes a long time to get a homogeneous mixture, just stirring the liquids together. Test it again, add more, test it. This is going to be a long process, because I don't want to overshoot. And once I get close, I'll just start adding the liquid in a little bit at a time from the pipette. Okay, there goes the foam. And that's just going to get worse over time as I bring the pH down. And just so I don't waste too much pH paper, I'll use the other end of this one to see what effect that's had. It's probably going to take a lot more than that to bring it down. Now, it's more blue than purple now, so that had a bit of an effect. Yeah, another reason you don't want to add too much at a time is not only the possibility of overshooting your target pH, but having foam over. We don't want foam over. A piece of paper here. Starting to look a little blue-green now, so we're down, probably down 10, 11, don't know, I would say maybe 12. I don't know. It's weird. Lots of stirring, and we'll try it again. Maybe I'll get a more reasonable indication. To tell it's still way too high, but it's like different areas of the strip are different colors. Now I don't know if it's showing up on camera, but as I bring the pH down, the color's lightening up a lot in the bulk liquid. Oh, now that's a big difference. Okay, now that's a big change. That's green now. That's easily 9. So we're down to 9. So we're making some progress. So, like I said, be careful. Like I almost wasn't there. The more you bring the pH down, the more it foams with each addition of acid. And then look how light it's getting. Let me get this good and stirred up. Measure it again. I hate measuring pH off the foam. See if I can get some liquid here. And measure the bulk liquid. Alright, so that's probably between 7 and 8, I would say. So we're getting close. Just a little bit more. I am not 100% certain what the gas is that's coming off. I suspect it's carbon dioxide. I don't know for sure. There's no real odor to it. I can tell you that. Now, one thing that does worry me a little bit about this Eco-Goldex stuff is I know it's a cyanide leach. It's a modified cyanide leach. And one thing I would worry about with this, and the first few times I used it, I did it only in my fume hood very carefully. I'm a little afraid that if I lower the pH too far too quickly, cyanide gas could be evolved. So far, that hasn't been a problem following these instructions. Okay, I would call that probably a solid 7. So I would say I am in the neighborhood where I need to switch to the more accurate pH strips and see what they're telling me. Look how light the liquid's gotten, by the way. Yeah, I would say that's pretty close to 7, maybe 7 1/4. I don't know how well that's showing up on the video. So I'm gonna just give it a couple of pipettes full here. Stir it up some more, measure it again. They're pretty particular about the pH range this needs to be in for the next step. We're going to do a zinc cementation to get gold back out of the liquid. And they are pretty specific about the pH range it needs to be in. So I try to get it just as close as I possibly can. We're still a little high, maybe 6 3/4. I'll give it a couple more shots. Yeah, so I would follow the directions that come with this stuff and use the citric acid to bring the pH down. I wouldn't cowboy it with something like muriatic acid or sulfuric acid. I think the odds that you might wind up evolving some cyanide gas would be pretty good. I'm not enough of an inorganic chemist to say that for sure, but it'd be something I would be worried about. Oh, I got 2 of them there. I am going to call that 6.5. That looks like, well, maybe still closer to 6.75. A couple more. One thing I have noticed about this stuff is that the pH has a tendency to drift up a little bit if you just, walk away from it during this process. So I'm not sure how stable the pH will be once you bring it down to the target. So once I get it down to the target, I get the zinc right in it. It's very foamy right now. There is a lot of gas in solution. It's going to pose some problems later. You'll see. Boy, that's getting tough to read there. I'm going to call that 6.5. I'm going to bring it down a little bit more so we're somewhere in the range between 6 and 6.5. Knowing from experience it tends to drift back up. The color change and opacity change is really remarkable since I started. Okay, I'm calling that 6.25. So I would say we were right in the middle of the range, maybe even a little closer to 6. So I am calling that good. So the next step is to put in some zinc. The instructions mainly talk about using sponge zinc. Don't have any sponge zinc, but I do have lots of zinc powder. The instructions are not clear on how much to use. Not clear at all. Now I figure there's probably, if I'm lucky, I doubt there's 2 grams of gold in this stuff. I really doubt it. I suspect I need to have more zinc than gold. So there's probably 3 or 4 grams, maybe even a little more of zinc right there. And I'm just going to put this in. And I'm going to thoroughly stir it in. Got some on the stir stick there. Wash it down in. Thoroughly stir it up. So what's supposed to be happening now is that the gold is cementing out on the particles of zinc metal. The instructions say I should let this sit and settle overnight. Oh, by the way, I'm supposed to be doing this whole thing at about 40 C. I think I said that up front, yeah. So the instructions say let this sit and settle overnight. I kind of deviate from the instructions a little bit. What I'll do is, during the course of the afternoon, I will stir this a couple of times. I'll let it settle, stir it, let it settle, stir it, and then tomorrow morning I'll come back and it should be all settled and I'll continue with the processing. But what I have found is there's so much gas in the solution right now that the zinc isn't going to settle out very well. It's going to form this thick, fluffy layer on the bottom that's just all full of gas. And unless you stir it to get some of the gas to come out of solution, it's just not going to settle good. So that's my deviation from the instructions that came with the Eco-Goldex. I just stir it, let it settle, stir it, let it settle, stir it, let it settle, then let it settle overnight. And then what I'll do is once the zinc has settled down into a layer near the bottom, I'll siphon off the bulk of the liquid and then filter off the zinc. I'll show you that when we get there. So for now, this is just going to sit, settle, stir, sit, settle, stir, and so on, and then I'll let it sit overnight. I'll see you tomorrow. Okay, it's the next day. This has been stirred and allowed to settle several times, and it's still very gassy, and it hasn't settled all that well. Let's see, yeah, there's still gas bubbles coming to the surface, and as they come up, they drag zinc off the bottom. And the zinc, look how thick the zinc layer on the bottom is. It's like a ½ inch thick. Now, I did not put that much zinc in there. There's only a few grams of zinc in there. So, this happens every time I do this, and my working theory is that the liquid is just so gassy that all of the little zinc particles have gas bubbles attached to them, and that's buoying them up so that they can't settle out into a thin layer on the bottom. Makes it a real pain to try and separate the zinc from the liquid. Your first inclination might be to vacuum filter this. Well, the liquid is so full of gas that it's going to be very foamy, and it'll foam right out the sidearm of your vacuum flask. That's happened to me. Gravity filtration, well, that's going to take forever because the little zinc particles that are still supported in the liquid there are going to plug up the holes in your filter pretty quick. Okay, what I have come up with is I'm going to siphon off the bulk of the liquid, maybe down to about the 400 milliliter mark or a little lower. That works fairly well. The problem with the siphoning is if I get even much lower than that, what's going to happen is little tendrils of zinc are going to start flying up off the bottom up the siphon hose in liquid currents. And I'm going to start losing a lot of the zinc. So I'm going to just siphon off the bulk of this liquid, and then I will vacuum filter the rest of it. And there shouldn't be so much there that it foams out the sidearm of my flask. At least I hope not. We'll see. So this first zinc cementation is always a pain in the butt because it's just so gassy and the zinc doesn't want to settle properly. Now, if you read the instructions on this stuff, they recommend 2 to 3 zinc cementations to get all of the gold out of here. But it's not the same procedure every time. For the first zinc cementation, we used the citric acid. The second zinc cementation, we're going to use a different reagent to adjust the pH, and that's going to be sodium metabisulfite. We're going to wind up with a lot less gassy mixture, and the zinc will settle to the bottom. But for this first one, it's always a pain in the butt. So let me get set up for siphoning. All right, gonna siphon. So let me fill this hose up with distilled water. Okay. Actually, the other way around. And here we go. It's going to take a little while. I'll probably speed up the video. We'll see how far down I can get before I start sucking the zinc up off the bottom, because it's not settled nicely on the bottom. Okay, that's as far down as I dare take it, because the zinc's starting to, it probably didn't show up on the video, but the zinc was starting to hump up towards the hose. And I don't want to bring the zinc over. So, that's as far as I'm going to go. Next step, I'm going to vacuum filter this and capture the zinc. Okay, let's see if I can get this stuff, what's left in there, vacuum filtered. Let's see here. capture that zinc. Try and just pour the liquid off first, but it's not easy. The zinc, yeah, the zinc gets mobile real easy. So once all the pores in this filter get clogged up with zinc, the filtration is going to go real slow. And you can see how foamy it is. There's still a lot of gas in that liquid. Actually, it's going a lot faster than I thought it would. I've had a lot more trouble with it in the past. And once you get the zinc filtered off, you need to wash it really good. Some component of this orange liquid will follow the zinc through the following processes if you don't rinse it out really, really good. I don't know what it is, but it'll keep reappearing. The volume of the liquid's going to keep increasing as I keep adding rinse water to it. Just unavoidable. So anyway, I'm going to rinse this really, really well in hopes that I don't see orange stuff showing up when I drop the gold out of solution later, because there's a problem I've had. I won't make you watch, this is going to take a little while. What I'm going to do is, after I'm done filtering, I'm going to put the zinc, I'm just going to pull the filter holding the zinc out and put it back in that big beaker. This stuff I'm going to pour in this beaker, and I'm going to get set up for the second zinc cementation step, which is a little different than the first one. They recommend 3 or more, just to be sure you get all the gold out of it. I've never got anything beyond the second one. You know, when I've gone to 3, it's like, there's nothing here really. Wasted a lot of time and reagents for nothing. But we will do 2 steps on camera. And I'll show you both of the cementation procedures they recommend. The first one was with the citric acid, and the second one was with sodium metabisulfite to adjust the pH. The pH on this has gone way up again. Don't ask me why. Strange inorganic chemistry going on in there. But after adding the zinc and cementing out some gold, the pH has gone way up again. It's probably up close to 13 again. So anyway, I'm going to rinse this a few more times, dump that in there, put that up in there, get set up for the next cementation. Alright, it's time for the second zinc cementation to get some more gold out of this mixture. See, it needs to be at 40°. It's right at 40°. I don't know how I did that. Let me turn it down now that it's up to temperature. And next I need to adjust the pH back down to, this time they say 7.3 in the instructions. Now, they say around 7.3. You know, for the first cementation, they gave a really tight range for the pH, but for the second one, they say around 7.3, which is, you know, kind of vague. And this time, instead of using citric acid, we're supposed to use sodium metabisulfite. So I've got a really strong, actually I think it's saturated solution of sodium metabisulfite here. And this is what I'm going to use to bring the pH down to 7.3. And I'm going to do like before, I'm going to start out with these rough pH papers, and once I get close, I'll go to the other pH sticks. That's not as high as I thought. It's only somewhere between 9 and 10, I guess. So it didn't go up as high as I thought it would. Still, we got a ways to come down. There is not the sort of foaming that you get with the first pH adjustment with citric acid. Didn't make too much of a difference. I'd say we're down to 9 now, so it's a little harder, but don't want to overshoot. By the way, I have the zinc from the first cementation in this beaker over here. And I don't know what causes the volume to grow like that. Is that showing on the video? It's like 10 to 20 times the volume of zinc I put in there. I don't know what's up with that. There's something besides zinc in there. Made it volume grow like that. I know it's not gold. I'm not that lucky. There's something else in it. Well, between 9 and 8, I guess. All right, so I would say that, yeah, that's between, that's 8-ish, I would say. I'm going to switch to the more accurate pH strips here and see what I'm getting before I put any more in. Yeah, I would say that is right at 8. Maybe a little lower than 8. Okay. So now we switch to using the pipette. Since I just need to get down to 7.3, I don't want to overdo it here. There's a lot less drama with this cementation. There's no foaming. Color changes tend to be subtle rather than dramatic. I'm going to call that 7.5. I think we're just a little bit high yet. Not much, just a little bit. Get it stirred really good. Make sure it's all more or less homogeneous here. So I'm getting a good reading. Not just from an eddy that's high or low. Well, that looks like That looks like right dead on 7 1/4. So that's about as close as I can get to 7.3 with these sticks. So I'm going to call that on target. So now we put the zinc in again. Same as last time. Again, they don't give you a good idea how much to put in. In the videos I've seen, they're putting in just huge amounts of zinc strips or zinc sponge. They talk a little bit about zinc powder as a viable alternative, but they don't really tell you how much to put in. I suspect there's not much gold left in there, but I'm going to put in a fair amount of zinc anyway. It's a few grams worth. Stir it up good. And I'm going to do the same thing I did with this last time. I'm going to stir this up a few times and let it settle. Stir it up, let it settle, stir it up, let it settle. Now, since there's a lot less gas in here this time around, this stuff is going to settle a lot quicker and easier. So I might be able to siphon the bulk off of the liquid yet today. Otherwise, it'll be tomorrow morning. And then I will add the zinc, once I get it out of here, to this zinc and process it all at once, rather than processing the first cementation separate from the second cementation. I'll just process it all at once. Quicker and more efficient that way. Anyway, I'll show you what it looks like once it settles for good, after I'm done stirring it up. Can you see how foamy it's starting to get? There's no foaming this time when I'm adjusting the pH. The foaming starts after I put the zinc in and stir it up. Then it starts getting foamy. It's just very strange how it behaves. Like the head on a beer there or something. Anyway, that will diminish. Well, it's the next day, and the zinc from the second cementation has settled to the bottom nicely. What I'm going to do is exactly what I did after the first cementation. I'm going to siphon it off down to about here or so, and then set up to vacuum filter the rest of it, and capture that zinc on a filter. And I'm probably not going to bother showing all this because, you know, it's exactly the same as I did the first time around. This video is getting long, so I'm going to cut out some of the repetitive stuff. So I will get back with you after I have the zinc from the bottom of this beaker captured. All right, siphoning's done, vacuum filtration's done, and I've got the 2 filters full of zinc from the 2 zinc cementations in this big beaker. Here's the remainder of the liquid. Now, the instructions say you can use the Stannous chloride test to test whether there's still gold in this liquid. I have had just horrible luck with the Stannous chloride test. I just did one, and it kind of looks like maybe positive, but the color isn't quite right for gold. It's sort of more of an orangey brown than purplish black. And like I said, I've had horrible luck with using the Stannous chloride test with this stuff. I suspect it's because of the very high pH of this liquid. And I think that's throwing the test off. I don't know. But I will get negatives when I know it's loaded with gold, and I'll get false positives when there doesn't seem to be anything left in it. So I don't know what's going on with it. Anyway, I suspect this is a false positive. I may do another extraction on this liquid just for funsies. I don't know. I don't expect to get much more gold out of it. I suspect 99.9% of the gold is probably sitting right here in this beaker right now. So it's up to you how many zinc cementations you want to do on this stuff. I normally stop after 2, but it's up to you. All right. Next step, I am going to add a few 100 milliliters of dilute hydrochloric acid to this zinc to get it to dissolve in the acid. And that should leave behind any gold. There'll be some black stuff left in there, and that should be gold. I'm going to do this in the fume hood. Up till now, I've been doing it out in the open where you can see and hear what's going on. This is going to produce a lot of nasty fumes, so I'm going to do this in the fume hood. Fume hood's loud, So I'll have to yell to hear, so you'll be able to hear what I'm saying. But I'm going to get set up for that, and I will be back in a second. Alright, I'm set up to dissolve the zinc. I got about 150 milliliters of concentrated hydrochloric acid here. I added a couple 100 milliliters of water to the beaker with the filters with the zinc in it. So I'm going to start up the fume hood. It's going to be loud. Now I'm going to add the acid. Fairly vigorous reaction going on in there. I'll stir that around a little bit and see if that'll dissolve all the zinc. I may add another shot of acid to it later just to make sure that all the zinc is dissolved. I'll show you what the result looks like. Here we are. The zinc's all dissolved. I put an extra shot of acid in it just to make sure that all the zinc got dissolved. A little bit more reaction, but not much, and now it's completely calmed down. I would say all the zinc is dissolved. There is a lot of black stuff on the bottom of the beaker. Let me see if I can get a shot at the bottom of the beaker. I hope that focuses. That black stuff is most likely good gold. So what I'm going to do is, one more time, I'm going to vacuum filter all this stuff. I'm going to capture all the black stuff in the bottom of the beaker. I'm going to capture the filters that are in there because there's black stuff caught on the filter paper. And I'm going to rinse it really thoroughly to try and get as much of the zinc chloride out of it as I can. So when it comes to dissolve the gold, I don't have that as a big impurity. So I'm going to get set up for one more vacuum filtration. Alright, one more vacuum filtration. Well, probably not the last one. I think I told you up front that getting the gold into the Eco-Goldex is pretty easy. Getting it back out, not so much. There's a lot of moving parts to the process. So let me filter this stuff off. Now this waste liquid should not contain any gold. Should just be hydrochloric acid and zinc chloride. That should be it. Never hurts to test it to be sure. Do a Stannous chloride test on it if you like. Never hurts to test your waste and make sure. I gotta get these filters in there too and rinse everything down good. Yeah, so this waste could go right into my waste acid bucket. Shouldn't be any problem there. All the gold should be up here on the filter. Yeah, there's a lot of black stuff in the bottom of this thing. There's some sort of blue precipitate too. Not sure what that is. I've seen it before. There's a whole laundry list of chemicals that go into making Eco-Goldex, and they'll provide that to you on the MSDS. But then, once they have all the chemicals mixed up, they put the whole thing in a kiln and they heat it up, and I think the process is called calcining or something, and it sort of melts together and makes a big clinker, which they then break up into the powder. So who knows what sort of chemical reactions go on in the kiln. So it's really hard to say what kind of chemistry we've got going on here. I don't know what this blue stuff is. See if I can get the filters down in there so I can wash them too. They're kind of breaking up on me. Guess I'll have to rinse them down in. Got some of the black stuff on the stir rod, and I don't want to lose any gold. Oh yeah, there we go. Get all the filters in. Get all the black stuff from the bottom of the beaker, which I'm pretty sure is gold powder. There we go. So I'm just going to rinse this stuff a couple times with distilled water to try and get as much of the zinc chloride out of it as I can. One less impurity to deal with down the road as I'm purifying the gold. Then we'll be in familiar territory. We'll be no more Eco-Goldex. It's just the process of purifying the gold, dissolving it in aqua regia, and then reprecipitating it. So I'll give this a couple of rinses, and then get set up to dissolve the gold in aqua regia. I'll show you that. Alright, it is finally time to dissolve the gold in aqua regia so that we can reprecipitate it and see what we got. So I've got some muriatic acid here, and I've got some of my homemade nitric acid here, and I'm going to go ahead and dissolve the gold. Now I've got all of the filtered material in here. There is a little bit of that blue precipitate in there. I don't know what it is. Usually the blue stuff isn't a problem. If you see orange stuff in there, that's a problem, because that'll dissolve in aqua regia and reprecipitate with the gold. The blue stuff generally gets left behind. So let's give it a shot. I'm going to give it a couple 100 milliliters of muriatic acid here. It's not that much gold in there, so I don't need to put a whole lot in. Turn the heat up some, because everything's cold here, and aqua regia works better around 70°C. I'm going to put in a couple of pipettes of nitric acid. My homemade concentrated red fuming nitric acid. I've got videos online that show how I make this stuff. A lot cheaper than buying it. We'll go with 2 pipettes for now and see what happens. Just let this warm up. The gold should start dissolving. All that filter paper in there should just fall to pulp. And let's see what we get. I'll show you. Well, the liquid's starting to warm up, getting a pretty vigorous reaction going on down in there. Some orange nitrogen dioxide fumes are starting to be evolved too. So I'm going to turn the heat back down, and we're just going to let it cook and see what happens. It was really pulpy and thick, and I'm wanting to foam up, so I added a little more hydrochloric acid to it just to thin it out some, and that seemed to help a lot. Anyway, it's looking a lot better now. It's been a little while. Everything seems to be dissolved. The filters have all turned into pulp and mush, and it's got sort of a yellow color to it, which is what I'm expecting since there's gold in it. The blue color's kind of gone away. Let's give it a little test just to make sure we've got some gold in solution here. Oh, and by the way, I put a little, about a milliliter of sulfuric acid in it too, concentrated sulfuric acid, just to precipitate out any lead that might be in there. I've got some fresh Stannous chloride solution back here that I just made just now. Look at that. Alright, so we got some gold in solution. So, now it's time to get the gold out of solution. I'm going to set up for one more vacuum filtration because this is looking pretty muddy. I know there's a lot of pulp in there from the filter material. There's whatever that blue precipitate was in there, so it all needs to be filtered out, and hopefully I'll get a nice, clean, clear, yellow filtrate that I can drop some fairly clean gold out of. We'll see. I will set up and get this vacuum filtering. Okay, I've got some sulfamic acid here. I'm going to denox this stuff. Stuff tends to get hard. You got to add this carefully and slowly, because if you got a lot of excess nitric in here, it can foam over. A little bit of a reaction, not too violent, that's good. So I guess I don't have too much excess nitric. The sulfamic acid converts any remaining nitric acid into sulfuric acid and nitrous oxide gas, which is where the foam comes from. But if you've got a lot of excess nitric and you put this stuff in too fast, it will boil over on you. I speak from experience. The amount of gas generated is just crazy if you've got a lot of nitric acid in there. This is looking pretty good. That's really not much of a reaction at all. I think once that stuff in there I've put in fully dissolves, they'll be denoxed. Okay. So, next I'm going to add some shaved ice to cool it down. Cool it down and dilute it. That should help any silver chloride, any lead sulfate in there. By cooling it down, that should help it precipitate out of solution, so that when I filter this, it'll all get caught on the filter and only the gold solution will go through. Alright, I'm going to get set up for vacuum filtration one more time. And we'll see what we get. Hopefully a nice crystal clear yellow liquid. That's what I'm hoping. We'll see. Okay, here we go. Vacuum filtration again. It's kind of turned a little green while it's been sitting here waiting for me to get started on this. Huh. There we go. There was a lot of blue stuff in there to start with, and we all know from the Ziploc commercials, yellow plus blue makes green. So, we'll see. See what we get. Well, it's looking pretty good so far. Nice and yellow down there. Maybe the blue stuff's staying behind in the filter. Okay, this is going to take a little while. I won't make you watch all of it. Once I get this vacuum filtered, it's going to go into a flask, and we'll be ready to drop the gold out of it with some sodium metabisulfite and see how much gold we recovered. Okay, filtration's done. The dark blue stuff stayed in the filter. Whatever that precipitate is, I have no idea what it is. The filtrate, fairly clear, slightly cloudy, just slightly. Some of that may be, yeah, not as cloudy as I thought. It's just because I put some rinse water in there and it was differing index of refraction. stir it up and it gets a lot clearer. Still very slightly cloudy, but that's the right color. Fairly clean looking stuff. So I will precipitate the gold out of that here in a bit. Put that in a beaker and put some SMB in it and see what we get. I'll show you that. Oh, and by the way, this filter is going in my used gold filters box. Since it has had gold solution run through it, I probably did not get all the gold out of it, so someday I will process all my filters and get the gold out of them. No waste. Waste not, want not. Alright, let me get set up to drop the gold. Alrighty, it is time to drop the gold out of solution and see what we got. I'm going to do this in the fume hood because the amount of sulfur dioxide gas that's going to be produced is really obnoxious. Don't want to breathe it. So when I start the fume hood up, it's going to be really loud. I've been doing most of this out in the open where you can see and hear me better, but for this just has to be done in the fume hood. The sulfur dioxide is just terrible. So, alright, I've got the solution of sodium metabisulfite over here that I was using to adjust the pH earlier. I'm going to dump this in. This may not be enough to make the gold drop. I've got some more powdered SMB here if I need it. I'm going to start the fume hood up. Going to be loud. And here we go. We'll see what that does. So far I'm not seeing the normal color change. Well, maybe. Yeah, there we go. Alright. There we go. From a nice clear yellow to a muddy brown. Yep, there we go. And I think I see... Yeah, I think I see some gold floating on the surface. So it's working. Alright. We'll just let that go and let that settle and see what we get. So there's the gold I recovered down the bottom of the big beaker. I will clean it up, weigh it up, and we'll see what we got. So those of you who have watched this far into the video, one question you may have, and it's a question I had too up front, what to do with the waste liquid? And this is a question I asked John at Eco-Goldex, and I didn't get a really good answer out of him. There's a little bit of shuck and jive there. You know, I was wondering, you know, what's in it, what's the proper way to dispose of it, that kind of thing, and I didn't really get a good answer. But if you look at the instructions that they send with the stuff on the flow chart about how to use it, they show the waste liquid here being recycled back to the beginning of the process and reused. And yeah, I suppose you could do that. In fact, I've done it. I've you know, made another batch of Eco-Goldex using the waste from a previous batch, and it doesn't seem to work, you know, any less well than making it with water does, like I did at the beginning of this. And that can be kind of a viable solution. The problem is, of course, I've got almost double the volume of liquid I started with because of all the rinse water that I used. So, you know, the liquid's going to pile up over time. You're not going to need as much for the next batch as you generate with the previous batch eventually. You know, you could start making this stuff in, you know, 20-liter buckets or, you know, swimming pools full of it if you want, but eventually you're going to wind up with waste liquid, and I'm not sure what to do with it. For now, I'm storing it. I suppose I could evaporate it off and then just get rid of whatever solids are left over. It's kind of time and energy intensive process, but it may be a viable option. Since I'm not sure what else to do with it, I suspect there's still some cyanide compounds in there. Probably considered hazardous waste everywhere in the world, so not something you want to dump down the drain or into the local drainage ditch. So yeah, what to do with the waste, that is a bit of a question. For now, I'm storing it and reusing it, but it piles up over time. So here's the final tally. 0.89 grams of gold. Right around what I was expecting. it always looks like more in the bottom of the beaker than it really is once you get it dried out and weigh it. But you know what? It only came from that much stuff. You know, 1 liter of solution, and I only processed about 1 liter of stuff through it. So that's not too bad. And if I was doing it with the AP solution, this stuff would still be soaking in AP solution for another week or more. So here I've already got the gold. Yeah, there's a lot of steps to the process. But, yeah, I got the gold and didn't have to dissolve the rest of the metal to get it. Now, you know, if you were mixing up 20-liter buckets of this stuff and running, you know, 100 kilograms of stuff through it, you'd get a lot more gold with just about the same amount of time and effort. So I'd have to say that this Eco-Goldex stuff, even though there's a lot of moving parts to it and a lot of steps involved, it does work pretty well for getting the gold off gold-plated stuff. You know, it has a few drawbacks. There's a lot of complication to it, and not sure what to do with the waste products, but it does work. So keep that in mind, and keep in mind the problem of having to pay a brokerage fee if you're not in Canada and you buy it, since that seems to be an issue. It's weird. The scale keeps ticking downwards. I guess my gold's evaporating. I better stop here before it goes to 0. Anyway, thanks for watching. I hope this was helpful. Keep it safe out there. Hey guys, here's an update on the gold leaching process. The footage you just saw in the previous part of this video was shot a while back and just recently edited together. I was just starting to get familiar with the Eco-Goldex and hadn't used it much yet, and it's a bit of a learning curve, but I've been using it for a while now. I'm getting more comfortable with it, and there's a couple of updates. For one thing, I'm going to scale up the process. I'll be making up Eco-Goldex in much larger batches in the future, and dunking stuff into it with a wire basket to strip the gold off. So that's my plan, to scale up the process. I'm getting a lot of gold-plated stuff that needs to be stripped. So that will allow me to scale up the process. And then for dealing with the waste, what I've started doing, once I get a couple of gallons of waste liquid together, what I'll do is I'll dump it in a 2-gallon bucket like this. I'll do one last zinc cementation on it. I'll adjust the pH. I mean, I'll put it out in the sun to get it warm. I mean, heck, it's summer in Florida. It's like 100 degrees out here. This has only got to be 40 C to work right. So, you know, I'll put it out in the sun for an hour and it's plenty warm. And I'll adjust the pH on it, and I'll do one last zinc cementation, siphon off the liquid, capture the zinc, get the gold out of it. You know, I wasn't getting too much on a third cementation with like 1 liter or 2 liters of the stuff, but on 2 gallons of it, if I do one last cementation on it, I do get, you know, a significant amount of gold out of it. So it's worth doing. And then once I do that, what I'm doing now is it's kind of energy intensive and wasteful, but I'm boiling down the liquid until it just, you know, crystallizes into a bunch of solid crap, and just disposing of the solid, because I don't know what else to do with it. I don't want to pour the liquid down the drain into our sewers. I don't want to pour it in the drainage ditch, you know. I don't know what else to do with it. I can't get a good answer out of Eco-Goldex about what to do with it. And I have found, you know, you can recycle this liquid, some of it, back to the beginning and reuse it again and again. I have found that it is, you know, after a couple of times, not so effective. There's a couple of issues. The new Eco-Goldex powder doesn't want to dissolve in it all that well. And then you get some strange precipitates down the road. So, you know, you can't recycle this stuff forever. So eventually you just got to evaporate it off and get rid of it, I guess. I can't think of a better way to do it. So that's just an update on what I'm doing. I'm going to be scaling up and I do 3rd or 4th extraction on the waste liquid before I get rid of it by evaporating it off. So just wanted to put that update on the end of this video, since I'm getting more comfortable using it, learning new things, and dealing with some of the issues involved. Thanks for watching. Bye.